required to return aircraft to an operational status after exposure to a burst. Shot day. The effects of an atomic bomb on aircraft. After a shot, we're all anxious to get back to our test setups and see for ourselves what happened. The data is here. It only needs to be recovered and analyzed in order to be applied to the plans and problems of atomic warfare. Among many other things, we learn that bombers do receive more damage than fighters. Jet aircraft generally sustain less damage. Planes in a side orientation to the burst receive the greatest damage. In all cases, damage is closely related to the height of burst, distance from ground zero, and kiloton yield of the bomb. Planes in some cases can be returned to operational status after exposure to an atomic detonation. Some can go into operation immediately. Hopefully, this program will give our military planners a great deal of new and vitally important offensive and defensive information. While we're trying all the time to better our position and approach to offensive use of atomic weapons, we're trying just as hard in the other direction to learn all we can about protection and defense against effects of the bomb. Normally in combat, when a man doesn't have something like a trench or a foxhole to seek shelter in, he takes advantage of whatever protection is available, such as a forest or heavy foliage. So we went to Mount Charleston near Las Vegas, selected and carefully removed some evergreen trees that were in perfect condition to bring to the test site. We've been making studies for years on the thermal characteristics in different forest situations. By pulling trees over, breaking them, and various other tests, we have developed some very reliable systems for estimating the static forces necessary to damage trees. Now we need to learn the reaction of trees to the dynamic forces and thermal radiation produced by atomic weapons. Once the trees arrived at the site on special trailers, they were carefully removed to minimize the amount of breakage and planted in concrete foundations at varying distances from ground zero. Since we know the breaking point of these trees pretty well, we're trying to place them in positions and at distances to measure how much the trees will bend under the shock wave forces. Then we know how much more it would take to break them. We're instrumenting the trees with strain gauges, scratch gauges, and other gauges. Some of our other trees are like something right out of science fiction. During the operation, they took on the nickname of lollipops. Actually, they're idealized tree models, consisting of flat metal plates mounted on steel beams. The lollipops are instrumented to help us determine the motion and bending strain on trees subjected to the fierce pressures in the shock wave. This combination of real and idealized model trees will also help us to get a good reading on the drag forces of tree crowns. Fires may be a discouraging factor, too. So we're setting out a variety of things that could ignite and burn in a forest. These are known as forest fuels, materials that might carpet the floor of any forest, such as logs, pine needles, beech leaves, cheatgrass, moss, and fir needles. The blast and fire of an atomic bomb are even more dangerous in populated areas. So we're exposing specimens of common structural details, covered and uncovered wall angles, some bare, some exposed with materials that will ignite easily, approximating inflammable trash found in almost any urban area, plus various types of roofing. All of these structural components are without defects that would tend to cause them to ignite or burn. All of this to determine the vulnerability of building components to ignition and sustained burning from atomic weapons. We're also setting up cubicles or miniature buildings to relate the study even more specifically to the problems of a city exposed to an atomic bomb. To find out what ignites inside, we're installing various types of furnishings, such as wood tables and chairs. This project is looking for primary ignitions, not secondary ones from overturned stoves or damaged electrical circuits. We're also going to be able to study the interaction between thermal radiation and the blast wave, and the characteristics of the blast wave in spreading or putting out fires. Our forestry line is ready. Shot day. About shockwave effect on our trees, we learned that they are fairly flexible even against the dynamic force of the bomb. There was a minimum amount of breakage and little damage from flying missiles. However, all of our stations did not come out unscathed. We found that with trees in good condition, generally good thermal protection will be available, thus lowering the degree of burning and the ultimate area of damage. But a full evaluation of their blast protection or hazards will depend on more extensive tests in the future. Our fuel samples were upright to provide the most ideal conditions for igniting and to help us find the limits of the bomb's ability to start and blow out fires. It is only relatively close in that the shock wave blows out a fire. Our miniature buildings and structural specimens gave us valuable data and confirmed many predictions. Sustained burning will not occur if structures in good condition are beyond the primary blast area. After the heat from the bomb has diminished, the fire will generally go out. There would probably be some ignitions through open and broken windows. Then we set out to broaden the foundation of knowledge on which we can reliably base troop participation in atomic warfare. First of all, we want to learn more about the effect of atomic bombs on the combat tools of ground troops. So we're going to let the blast work over a wide range of implements used by soldiers in the field. A cross-section of everything that rolls or shoots will be exposed in a variety of orientations to the bursts and at several distances from the detonation, from large artillery units and heavy machine guns to light weapon emplacements. Shot day. Camp Desert Rock. H-5 hours. Throughout much of recorded military history, it's clear that the effectiveness of troops is geared to their psychological attitude toward the weapons used and situations encountered. At their base camp, Desert Rock, these men are mustering for an atomic warfare maneuver, only the second series of its kind in history. Though they're very much a part of Tumbler Snapper, they operate independently as they would on a military maneuver. They've all been thoroughly briefed on the hazards, precautions, and techniques of their tactical operations in the area of a nuclear detonation. After the time check, the word is roll out. Every man is accounted for. Every man has his own film badge to record the degree of his own personal exposure. Every group is accompanied by trained radiological safety monitors to be with them in the contaminated areas. Yucca Flat, Desert Rock Entrenchment Area, 4 miles from Ground Zero. H minus 90 minutes. Like all too many people, both in and out of the military, before these men got their assignment for this operation, they had many misconceptions about the bomb and its effects. Some of them thought they would never again be able to have families. Some of them expected to be deaf or blind. Some of them expected to glow for hours after the bomb went off. Like so many people, many of them were afraid. They had never taken the time or invested the effort to learn the facts about what to do in case of atomic warfare. These men have been indoctrinated in what goes on and what to do when the bomb goes off. Any doubts that are left will be eliminated after the full experience of this operation. Planning level observers from throughout the defense establishment have an opportunity to study the maneuvers from close range. H hour minus 5 minutes.
May I have your attention? The B-50 type aircraft you see overhead is the drop plane on its bombing run. The time of fall will be 40 seconds. You will hear the countdown from the bomb away until the first time. Remain in your holds until the command raise has been given at H plus 3 seconds. If you stand up too soon, the intense light will temporarily blind you, and the heat will give you the equivalent of a severe sunburn. When the command raise has been given, stand up and lean against the rear of your foxhole. This will brace you against the shock wave, which will arrive at this point at burst time plus 25 seconds. It is now H minus 2 minutes. Everyone kneel down in your foxholes, look down, and stay down.